Okay. Yeah, so the recording has started. So let me introduce myself. So I am Dibbanan Bandhavadhai from Indian Institute of Technology, Patna. I'm currently a PMRF scholar. So I'm handling the responsibility of this course TA to actually interact with you guys and actually hold a session every Saturday and discuss some problems for 2 hours. So this is the responsibility that I'm handling this year as a part of this course. So yeah, so let us begin. So in the first week, actually, we'll basically discuss about very basic things. And yeah, let me share my screen. I think you guys can see it, right? You guys can see the screen, right? Anybody confirm?
Yes, sir.
Yes, sir.
Okay, okay, fine. Yeah. So this week is basically all about very basic things in C. So I guess you are familiar with the basic architecture of the computer, mostly about how it works and what are the components that are there as a part of the computer. So we'll see one by one and basic questions pertaining to each of the things. So yeah. So this is the first question that we'll see. So a set of instruction to be provided to an electronic machine is called what? So there are four options and the options are quite similar actually. So what is the set of instructions? So let us suppose that you have to perform an addition task. And for performing that addition task, you want to instruct that electronic machine how can this be performed. So there are a specific set of instruction. So how can it be performed? You have to basically instruct the electronic machine in step-by-step manner. So first will be to actually assign one number to one particular variable. Let's say you want to sum 5 plus 10. So how can you do that? So you have to have some mechanism such that you can place that number 5 to that bin X, right? And so, let's suppose X is a bin and you place that number 5 to that X to that bin X. And similarly, let's suppose another bin is Y and you place that second number 15 into that place Y, right? Then they are basically declaring those variables X and Y. And after declaring those variables, you basically say Z. You declare another variable which is sum of X and Y. So Z equal to X plus Y. And that is why these are the three sets of instruction that basically instructs the machine to actually perform the summation operation. So you basically declare X equal to 10, then Y equal to 5, and then basically Z equal to X plus Y, and then print Z. So this is by following these four operations, the machine will actually print, will do the summation of 10 plus 5, and it will basically print the value of 5. So this is how this is done actually. So this set of instruction that I told you, so what is this called actually? There are four options: programming, processing, computing, and compiling. So programming, I think, can be one of the option, right? Because it is basically your instructing the machine to perform a job. Processing also one of the option. Computing also one of the option, and compiling also a part of the process actually. So let's see what of the optimal answer. So the optimal answer is basically programming. Why not processing, computing, and compiling? Because they are part of the process, not the whole overall process. So when you provide the set of instruction to the electronic machine and expect it to get the answer from it, then the whole process, it is called programming. So it is as simple as that actually. Compiling is basically understanding, make the machine understand whatever you have provided. So that is the compiling process. After compilation, the machine actually executes the instruction. That is computing, and the whole thing is basically called processing. But the end-to-end thing where you write the instruction, the set of instruction, and then uh, the set of instruction that you provide, that is the programming actually. So this is the question two. Uh, Computer helps in translation from integer to binary, high level program to binary digits, high level language to machine level language, and high level language pseudocode to computer program. So let's understand what this means one by one actually. So what is integer? Integer is basically 0 to 9. These are all the integers actually, and other numbers, whole numbers basically. And what is binary? Binary is basically represented in 0 and 1. So any number can be represented in binary, and integer are basically whole numbers. So do you think that computer actually helps you to only translate from integer to binary? Certainly, this is not the case because computers can handle multiple tasks actually. Maybe translation from integer to binary is part of the task, but it is not the whole task. So yeah, this can be ruled out then, right? So the second option is high level program to binary digits. This is another the same thing. So everybody knows that if you give some program to a computer, basically you expect it to give you some output, and how the process is done everybody knows that it basically converts it into binary digits, compiler combination of zeros and ones, and then that combination of zeros and ones are basically provided to some machinery of the computer. It processes it is and produce the output, and you see the output in the screen. So this is how the whole thing actually goes on. But high level program to binary digits, this is a part of the process, not the whole process. So this can also be ruled out, right? So this is the another option, high level language to machine level language. So computer does perform that actually. So you program in some high level language, let's say in Python, and then it actually gets converted into some machine level language, right? So these are part of the process actually. And this is pseudocode to computer program. So you provide pseudocode to computer program? I don't think so. Everybody actually provides right in high level language. Let's say a high level language is C or Python. Python is a high level language, let's say. So these A, B, and D, these are the tasks that computer perform. Maybe D is not about computer at all actually, because computer cannot handle pseudocode. So D we can directly rule out. A, B are remaining. Out of A, B, actually these are part of the process, but C is the whole process actually. If you provide high level language to a computer, it will convert it to a machine level language. Okay, so C is the answer. So these are very simple questions actually. Just everybody who knows computers and how they basically work will be able to answer these questions. So this is question number 3. So what is ALU actually? This is a very, yeah. Any questions? Okay. So let me proceed. So this is question number 3, the ALU unit of a computer, and these are the options actually. So ALU, if you know the full form of ALU, you will be able to answer this question because it is very simple actually. ALU means arithmetic logic unit. So every computer inside the microprocessor, there are a series of actually processes actually. I mean, inside the microprocessor, there are a series of transistors that makes gates actually, logic gates we call it. And those gates actually are formed in such a manner. There are several things that we will study in computer architecture, and mostly those gates actually give rise to a hardware, piece of hardware that is called the arithmetic logic unit. So the performance, the task of this ALU unit, this is a piece of hardware that is inside the microprocessor, inside the computer. The part of it is to basically do all the arithmetic operation and the logical operation. So that is why it is called arithmetic logic unit. So by arithmetic operation, I mean that if you are provided with, let's say, two numbers, then it will be able to actually add, subtract those two numbers, and also multiply and divide them. Okay, so these are the four basic arithmetic operation. And the logical operation is basically, let's suppose you are given a two binary string, so compilation of one and zeros actually, 1 0 0 0 1 1, let's say this is the first thing, and the second number is, let's say, 0 0 0 1 1 1. So these are the two numbers that you are given basically. Then the arithmetic logic unit actually takes these two numbers, actually perform both arithmetic and logical operation on top of these two strings. That is its task actually, and provide the output. So this is that C is the output because it can perform both arithmetic and logical operation. Yeah. So any question? Yeah. Hmm. I don't think there are any questions, so yeah, maybe I can proceed then. Okay. So yeah, question question for yeah. Hmm. Yeah, so this is question 4 actually.
Sir,
What type of Hi.
sir, in second question,
Hmm.
computer helps in the translation from high level program to machine level language, no, sir.
Right, right,
You
right.
have given, sir. I think it's compiler, no, sir. Compiler helps in translation from, or a computer as a whole, sir.
Actually, yeah, a computer as a whole actually, I mean, compiler is a part of the computer. So mainly this should be actually compiler can be a better answer for this. But as compiler is a part of computer, you can also think that computer actually handles the translation from high level to machine level language.
Sir. Uh,
Compiler is definitely
Compiler
true.
up to
Yes.
machine.
Compiler does that
Compiler does
actually.
it uh, up to machine level language only, no, sir. But computer
Yes, yes.
take it to the binary digit level, no, sir.
Yeah, you can think like that actually. So computer does everything actually. So it takes the language, it converts into machine level language. Machine level language actually then gets converted to binary digits. Then it performs the operation on top of them and produce the output. So the whole thing is basically computer, and all of them are correct. But compiler is basically the part that actually specifically handles C actually, high level to machine level language. You are correct actually. So compiler should have been the more better uh, question using this. Okay. So this is question 4. What type of device is a computer printer? So what do you think actually? Because there are several candidates: memory, output, storage, and input. So memory device means what actually? So suppose that uh, you have a computer, and inside the computer you can think of the computer like a box actually. So inside the computer there is memory and storage, and there is one input that is coming into the computer, and that is one output that is coming out of the computer. Not one actually, multiple input can be coming in and multiple output can be coming out. And there can be storage and memory inside the computer. So what is the difference between storage and memory? There is another thing inside the computer called the processing unit. So we'll think about that later. So memory is basically about this thing, RAM. So whatever is stored, the program and the operating system, when they are loaded, when you boot up the computer, they are loaded into the RAM. So that is the part of the memory that is volatile basically. That is basically very fast, and that is RAM. That is called the memory. And storage is basically your hard disk. So all the things that are stored in the hard disk, that is part of the storage. And what is then computer printer? Computer printer is neither memory, because you don't store anything in computer printer. Is it input? I don't think it is input, but because the input to the computer is basically your, I mean, power, right? That is the input, and it is part of the storage. I don't think so, because you don't store anything. Hard disk is not stored in computer, so only thing is remaining is output actually. So computer printer is a part of an output device actually. Whatever you are getting, generating from the computer, you are basically providing that into the computer printer to print it. So it is a part of the output unit. So I think, yeah. So what statement correctly distinguishes an algorithm from a program actually? So these are the four. Uh, Categories actually. So what do you think actually? So the algorithm and a program, what is the difference between them? So the first one is an algorithm is written in machine code, while a program is written in English. B is an algorithm is a step-by-step execution solution, whereas a program in its implementation is in a programming language. An algorithm can only be executed by a program. There is no difference between an algorithm and a program. So what do you think actually? Algorithm is basically the steps that you use to solve a problem. So let's suppose that you are given two things. You are given you are giving an instruction to the computer to sum two numbers actually. So the way that you write to solve this problem, basically the first step is uh, getting one digit. Let's say you are trying to sum two things, x and y, and storing that into z. The same example that I have given you earlier also. So x will be 5, y will be 10, and z will be x plus y. So these are the three steps, and then print z will be the value of the z will be printed to the machine. I mean the output or the screen. So these are the four steps that actually is how you are instructing the computer to perform a operation. That is the algorithm. And what is program actually? Program is basically you are if you directly tell it in English language, let's say that please assign value of 5 to x. Then number two, please assign number of 10 to y, and then sum them. Z should be equal to x plus y, and then print the sum z. If you write in English to the computer, it will not understand. Maybe ChatGPT can understand, but I don't think computer will be able to understand. So these four steps that are how to perform the job. This is basically your uh, algorithm, the steps-by-step operation that you need to perform. But how can you translate this set of instruction such that computer can understand? That is your programming. The implementation, that is the program, right? So implementation of the algorithm in some way such that the computer can understand it is basically the program. So in one step, that is the algorithm, step-by-step thing that you can think on your mind and write in pseudocode, that is the algorithm. And when you actually concretely write it in some programming language, that is the program actually. So this is the difference between algorithm and program. So you can see here the algorithm is a step-by-step solution. So you can write it in English, in pseudocode, in any language, whatever you in whatever way you want actually. As long as there is a step-by-step process to solve the problem, that is an algorithm. And as long as you correctly translate it into a programming language such that a computer can understand it, it is basically a program. So this is the difference between algorithm and a program. So any questions up to this? Okay, so let's proceed then. So now let's suppose you are given three variables, A, B, and C. So after that, let's suppose these are the operations you are performing. Okay. So A equal to 15, B equal to A, and A equal to 20. So after performing the operation, what will be the value of A, B, and C? So these are the four options. Okay. So C value is not given, but I'll ask you later what will be the value of C. So so what do you think? Can you think of an answer actually? How to solve this question? Anybody can tell me any answer. These are the four options actually. What option do you think is correct? Can you tell me? You can chat maybe in the Teams chat. C, right? Okay. Okay. Anybody can explain why it is C? I'll also explain, but in short, can anybody explain?
So may I? I'm
Yes,
Shruti.
yes, sure, sure, sure. Go ahead.
So computer is like a memory. It saves its memory in a chip. So
Hmm.
it solves this problem step by step or line wise. So
Hmm.
according to the first step, the value of A was 15. It moves to the
Hmm.
second line. The
Hmm.
value of B was equals to A. So the value of B is now equals to 15.
Mm.
In the third line, the value of A is stated as 20. So the
Mm.
memory or the chip where this memory of 15 was stored will be replaced by 20 now.
Mm.
Hence, the output for A will be 20 and B will be 15.
Correct. Yes, very good. So let me explain what Suti actually explained in a more detailed way. So let's suppose that A and B, what are these things actually? They are variables that you declare. Okay. So when you C is correct, actually, it will be executed line by line. So this will be executed first, then this line will be executed, then this third line will be executed. Okay. So when you write this program, let's say A equal to 15, then what happens inside the computer? So when you write A equal to 15, and a variable named A will be basically registered in the register actually. There is a part of the hardware called register where A will be there posited, and correspondingly for A, there will be a memory location that will be allocated. So inside that particular memory, that this value 515 will be created. So yeah, so let's suppose that A is allocated the location 15, sorry, not location 15, let's say 156, arbitrary location, let's take it. In the location 156, this value will be allocated inside the RAM. In the second operation, when we assign B equal to A, then B will be assigned one arbitrary location inside the RAM. Let's suppose it is 256. And when you assign like this, B equal to A, what's the value of A that was uh, given in location 156? It was basically 15. So whatever value is having at location 156, that will be also be copied to the location represented by B. So this is location 256. So whenever you declare one variable, in the left hand side, whenever you see one variable, you have to imagine that inside the RAM some arbitrary position is allocated, and whatever is in the right hand side of the operation, that specific value is basically posited, or I mean directly given to that particular position, written to that particular position. So that is how the variable operation steps are done. So if you follow through these steps properly, then you will be able to see that age is assigned a value of 15, means there is some location in the RAM where value of 15 is assigned or put. After that, when you give B equal to A, there is another position in the RAM where the value, what is written in 156 position, that is also written in that position provided by B. So B also has the now has the same value. And after that, you don't change B. B is as it is, but you update the value of A. So B's value was 15, and now A's value will be 20. So C is the correct answer actually. So A equal to 20, B equal to 15, right? So you can see the steps. A equal to 15 stores the value 15 in the memory location assigned to A. B equal to A copies the value of A, what is 15, into a separate memory location assigned to B. And then A equal to 20 changes only the value stored in A. B remains 15 because it stored an independent copy of the value, right? So whenever you see this operation, you have to see from the standpoint of memory, because it will be very important when you uh, actually learn value and copy by reference and copy by value. This kind of things will be there in the C programming, and the memory of also when you learn structure and pointer, then these things will be very important actually. How the referencing process is done inside the memory location. So this is why it is very important. So now actually there is a part of the question: what is the value of C? Do you see C anywhere? So can anybody answer this actually? What will be the value of C? Will the computer be able to, if you execute this program, and in the last line if you see print C, let's say, then will the computer be able to print C or not?
No,
Sir,
because
I
we
think,
haven't defined a variable C.
Right.
sir, I think
So
it will
what,
print a junk value, sir.
it will print or it will not print?
It will print a junk value.
If it is not defined, then it cannot print anything, right? So if you just let's say int C, if you just declare it like that, then if you print it, it will print something junk value. But if you do not declare it actually, then will it print anything? So that's the question. So think about it actually. Okay. So
Displays
there is
error.
yeah. Go ahead.
Sir, memory variable not assigned like that, will it come, sir?
Right. So there is two distinction actually. If you declare one variable and don't assign a value to it, then that means that in a memory location, let's say you in C, I don't know if you have known this variable declaration or not. So let's suppose int a and then semicolon. This is how you define one variable, right? And after defining that, if you don't assign a number to it, there will be one particular memory location where that the variable will be assigned. There will be one particular memory location where the variable name will be assigned, right? That memory location will contain garbage value because you have not assigned any value to that particular location, memory location. And then if you print it, it will print some garbage value. But if you don't declare it in the program itself, let's suppose you do not even declare int c, then you try to print it. It will not print anything actually. The program will exit compilation error, right? So there is two distinction actually. So the define and the declaration of the variable are two distinct steps that you have to know while answering this kind of questions. Yeah, so I think it is clear out, right? So let me proceed.
Sir,
to
by
the,
junk value, you mean any random number, sir?
yes, any random number, right? So the reason is that in RAM actually, if you don't write anything to a particular memory location inside the RAM, then it will be filled with junk values because I frankly don't know the exact reason why this happens, but basically they are not filled with proper values that you have already assigned to the using the program itself, right? So that is why if you print something, then it will be junk value if you have not assigned anything to it, right? So let's suppose that you declare int a, then stop it. Then suppose you say print a. So int a, you just declare the variable and you print it, then it will print garbage value because no value has been assigned to the particular memory location indexed by a, right? So that is why how it is works actually. Any other question? Okay, so if you don't have any question, then you can proceed. Next question. Yeah. So this is one flow chart actually, and input n from user is 6, and what is the output of the algorithm? So this is one flow chart given. Sorry. Yeah, so this is the flow chart actually, and based on the flow chart, you have to answer these questions. So flow chart is one of the way that you can represent algorithms actually. So algorithms you can write in step-by-step manner, and flowchart is also one of the mechanism by which you can represent algorithm in a very precise manner actually. Lots of difficult algorithms you can use flowchart to represent. So this is a beautiful tool to actually show algorithms, right? And flowchart actually starts like that. So there is a start state. From start, you basically begin to perform the operation step-by-step manner. So this is that, let's say, start state, and you read n. Read n means basically n value is provided to you, and after that in the rectangular box, these are the variable values that are assigned initially. Okay, then if I greater than or equal to n, then if that step actually happens in the diamond box, you basically write the condition if else statement. So if this happens, yes, if the result of this operation is yes, then you do this operation, right? And after that you do this operation, and after doing this operation you go back to this step, because you follow the arrow basically, right? You basically come to this diamond box, you see whether the performance operation is yes or no, and based on the arrow you go to the next step. So if the operation is basically I greater or equal to n is yes, then you go follow the yes and go to this step. If the operation comes as no, you follow the arrow and go to this step. So this is how the algorithm actually works. This is how the flowchart, you have to read the flowchart. So by this manner, if you read this flowchart, and if the value input value is 6, okay, so what will happen actually? What will be the output of X? So the output will be this print X. You need to print X. So what will be the output of X if n is 6? Can anybody answer? I'll explain actually. So I want you to think also.
1,
One, sir.
How? How?
The
because
loop will be
according
yes.
Please, anybody go ahead. Anyone?
The first computer read the n value, that is
Hmm.
6. Next, the check the condition I less than or equal to n.
Hmm.
First, I equal to 1. I less than
Hmm.
or equal to 6 is the wrong condition, so that loop will be executed. Print x means given value x
Hmm.
equal to 1. So printed
Hmm.
value.
Correct. So let me explain again to everybody. So let's suppose this is read n actually. So read n means 6. You read 6 from the computer and you go to this step where you assign these values. After assigning this value, you go to this step and then you check the value of I and n, right? So I is assigned the value of 1 and n, I have said in the question, it is value of 6 actually. So do you think that I is greater or equal to n? I is 1, n is 6, so it is definitely less or equal to. Then it is no actually, right? Then it follows the no this label and actually follows this arrow to go to this and it actually print x. So what x was assigned in this time in the previous step, it is assigned a value of 1. So it will print 1 and the algorithm will stop. So this is how you have to read it. Now suppose instead of 6, it is some value which is basically lesser than what is that called? I, right? So let's suppose n from user is now 0. Then what to do? Then read 0 here. You come here, I equal to 1, x equal to 1. Then you go here, right? You have to go here because there is no other way around actually. You have to go because you follow the arrows only. If you come here, then you see that value of I is actually 1 because we have assigned it 1 and the value of n is 0. As I have said you that the computer did 0. Then after seeing this, you can see that it is actually greater or equal to, right? Because it is lesser. I mean, I is greater or equal to n. So you follow this step, yes, now, because it is happening. And then you increment the value of I to I plus 1. So now the value of I will be what? 2, because previously I was 1 and now the value of I will be 2. And then you multiply x with, see, you are doing the variable operation thing again. So left hand side, the value of x, this is the new value of x that will be assigned, and this is the in the right hand side, this is the current value of x, right? So the current value of x is 1, the current value of I from the previous step is 2. So you multiply 1 with 2 and you assign the new value of x as 2 and you again go back to this step actually, right? So I or I less than or equal to n, yes, it is true because n is 0, I is now 2. Then it again goes into this step. So the new value of I will be 2 plus 1 equal to 3. Then it goes again to this step. Then it multiplies the value of x and the value of I. So the value of I is 3. The value of x from the previous step was 2. So it actually multiplies 2 into 3, 6. So the new value of x is now 6. So it again goes back to this step. So it will basically continue like that. So it is infinite loop. What do you think? It is infinite loop, and is there a pattern you can see here? So what does this algorithm is doing? So it is 6, right? If
Infinite
you
loop.
come infinite loop, right? Yeah, it will never break actually. So now the value of x is 6. If you come back again, I equal to I greater than equal to n. Yes, because value of I is now what? 2, right? Yes, 2, and the value of n is 0. And basically you come here, it is now 3, the value of I is incremented to 3 and the value of 3 will be multiplied with 6. So it is 18 now, 6 into 3, right? So the value of x is now 18, so it goes again back here and the value will continue like that. So it will never terminate and the computer will go on infinitely.
Sir,
And yeah, Yeah.
sir, here we defined if n is taken as 6 value now, sir.
N is?
Here I, sir,
Hmm.
n value we have
Mhm.
given 6, sir. I
Mhm.
value is 1, no, sir. Since 1 is they given I equal is greater than or equal to n. So I is 1 greater than or equal to 6 means it is no, no, sir. So
No,
we will
no,
come
yes,
to
yes.
print text stop.
Correct, correct, correct. No, no, that is correct. It's absolutely correct. I was giving you one example when the value of n was 0 instead of 6. So, right. So I was
Okay,
giving
okay.
that example.
Yes, sir.
Yeah, yeah. If it is n, it will go to the no and it will print the value of x, which is 1. It is correct. I was just going through the example to see how to read the flowchart actually. So if the value of n is 0, then it will go to no and it will print the value of x, which is basically 1. But if it is lesser than or equal to I, then it will go into this infinite loop actually. It will never terminate. So that is what I actually trying to say and actually see how the value of x actually changes. So yeah, I
Sir,
think you understood. Yeah, yeah.
in real
Go ahead.
life, if we write code like this, what will happen to computer, sir? It will continuously loop in. It will be in loop, sir.
Yeah, it will be in loop. You have to just type Control C to exit from the program. Otherwise, the computer will crash. So it will continue doing the operation, and it will keep on printing the things. And after that, it will crash basically. You have to just restart the computer. Yeah, you can try it actually, and then you can restart. So it will crash. Yeah. So yeah, so this is the explanation. Read n equal to 6, initialize I equal to 1, and x equal to 1. And the decision checks actually I greater than or equal to n or not. If it is yes, then you go here, do the operations here, and then come back again here. If it is no, you just directly go here and print x, which is basically 1. So this is how you do it actually. And then there is another flowchart. So yeah, so this is the algorithm. Start, read numbers x equal to 5, then x is assign the value of y, then this is the operation being performed, and print y stop. So what do you think will be the output here? See the operations very carefully actually, because it is not directly very easy. So see the operations very carefully. So this is simple actually. Start state and then you read the number of x equal to 5. So x is assigned a value of 5. Then you perform this two operations. Yeah, go ahead.
$52 will be the answer.
No.
Compilation error.
51, sir.
52 answer,
Who is saying 52?
51 will be the answer, sir.
No, I don't think so. Somebody said compilation error. So can he or she explain actually?
It's a
No. Yeah,
compilation
go ahead.
error. I told compilation error because first we'll start and then read number x equals to 5. Second step, the value of x was changed to x equals to y. Now the value of x will be equal to y, which we haven't defined yet. In next step, the value of y was stated as y equals to x. So it will be y equals to y. The value of x wasn't defined. So until and unless we know what is the value of y, how will we multiply and solve it?
Yes. Yes, that is correct actually. And whoever has said 51 or 52, can anybody explain actually why we have said it? So yeah. Yeah, so let me explain actually why it is not 51 or 52. So the see the how the operations are defined actually. See, x equal to 5 means you have to read from left to right when you assign the variables actually. X equal to 5 means there is a value of 5 which you basically provide to x, right? Then x equal to y, what does it mean? You have to read from left to right. So y is some kind of variable and the value of y you are assigning to x. But have you defined y anywhere in the above part actually? Here, y is not defined. So when you assign y, let's say even if it is written in the program like int y, some value will be assigned actually, right? But that will be garbage value because we directly did not assign anything to y. So if you assign like this actually, this x will also have now garbage value. You initially assigned x equal to 5, but now you are assigning x equal to y, which is not even defined. So either in the best case scenario, it will be garbage value, or if it is not defined, y is not defined at all, then in this part itself, the program will throw an compilation error actually. So yeah, this flowchart is here to make you understand how to read the variable assignment. You always have to read from left to right actually. Sorry, right to left. Normally we do it from left to right in a normal manner. So if we say x equal to 5, then we think that x is equal to 5. That is not the case here. When x equal to 5, then you should read it like that. 5, the value of 5 is assigned to a variable named x. So if you read this x equal to y, then you should read it like that. The value of y is assigned to the variable named x. But then you should think, is y having any value here or not? Y is not having any value. So yeah, so this operation is not permitted, right? So this is how you should read these things actually. That is why this question was given to make the concept clear. Okay. So yeah, so the input steps initializes only x equal to 5. Y is never initialized. That is why I mean yeah, the problem is happening. Okay. So any questions regarding this? This is a important concept actually. Anybody have any question?
Sir, or
Mhm.
suppose in third step, if y equal to x,
Mhm.
then in bottom plus it is y by 2 or y percentage 2, sir. What does it mean, sir?
Yeah, it is y percentage 2 actually, not y by 2. So it means remainder. Okay. So suppose the value of y is 11 and you do this operation y equal to z equal to y percentage 2. So what will happen is that you divide y by 2, which is basically 11. Then how can you divide 2 into 5 plus 1? So this is the operation, right? You have to make the value of 11. So the remainder will be 1. So that is basically this operation, what it does. Do you understand, or should I again tell you? So this is the remainder actually. So if you divide by 2, whatever remainder will remain, that is the value of y percentage 2. So for an example, if y is 10, then y divided by 2, there is no remainder, so this will be 0. If y equal to 11, if you perform this operation, the remainder will be 1. So the value of y percentage 2 will be 1. Understand?
Yes, sir. Yes.
Okay. Okay, so if
Excuse
there
me,
is
sir.
no, yeah, sure, go ahead.
Sir, you said that y will store some garbage value, right? So
Hmm.
when we assigned x as y, x
Hmm.
will be storing some garbage value. In
Right.
fourth step, when we compute y assigned as x into 10 and then add y percentage to, then
Hmm.
finally y will store definitely some value, right, sir? Then
Correct,
when we
correct.
print y, we'll
Hmm.
get some another garbage value, but why do we get compilation errors?
Correct. That is a good question. So it is whatever you told is assuming that y is assigned some value. I mean, y is even declared in the program. But here in the above part, there is nowhere it is written that y is declared. I was taking an assumption that if the y is declared in the program, let's say int y, that's it. You don't assign any value. Then int y will be declared, y is as a variable will be declared. It will be assigned one garbage value, and that's it basically. Then you will get some garbage output. But if you don't declare y anywhere in the program, then it will throw a compilation error. So yeah.
Okay.
Yeah, so let me proceed then. Any other clarification you need? Anybody? What is this? Same thing. Okay. This is question number 9. Yeah. Yeah, sure. Go ahead. If there is no question, then this is question 9 actually. So again, on flowchart based question. So this is start and this is read x, and you perform some operation on here actually. And based on the operation, if the value of the operation is no, then you say x is odd number, and if it is yes, x is even number, and you stop. So my question to you is, what is the operation that you have to perform here actually, out of these 4 options? So this is the question. And diamond always means that there is some operation.
Option C, x by 2.
Option D, sir.
Option D, sir.
X modulus 2.
Option
D, sir.
Option D.
Okay. So why option D? And why not option C?
The modulus will be taken if percentage by 2, that is if reminder is 0, then it is even, otherwise odd.
And I think C can also be correct, right? Or why it is not correct?
Because
Sir, C.
C only gives the quotient, which we had to check whether the remainder is 0 or not. That only decides whether the number is even or odd.
Yes. Yeah. I think it is very simple actually. Yeah. Go ahead.
Get some number not equal to 0.
I could not hear you. Can you repeat again?
Sir, in question we get some particular number which is not equal to 0, sir.
Correct. So if you do this actually, correct. So if you perform the 4th operation, then what does it mean actually? So let's take any number. If it is a multiple of 2, this is basically even. And if it is not, it is odd, right? So this is the criteria of even and odd. So let's suppose x is 4. If you divide it by 4, and what will be the remainder actually? So sorry, divide by 2, what will be the remainder? 0. Then that is what is shown here actually, right? So let's suppose it is 4. If you take the modulo with 2, it will be 0. Then if it is 0, then if you know it is even, because if you take the modulo and if it gives you 0, then it means that it is a multiple of 2. So take any number. If you are successfully able to divide it by 0 without any remainder, then it is an even number. Otherwise, it is an odd number. As simple as that actually. So how to define the remainder? Using the modulo. So you take the modulo of x with respect to 2. If you get 0, then it is even, or otherwise it is odd. As simple as that. Okay. So this is the final answer. So x modulo 2 equal to 0. So let's take another example. Let's say 5. If you place 5 here, 5 modulo 2 will be what? 1. Then it will be odd actually. So you check this thing. If it is 0, it is even. If it is not, it is odd. So let's take another example. Let's say 13. So it will be 1 actually. 13 modulo 2. 2 into 6 will be 12. 1 will be the remainder. So x modulo 2 when x is 13 is equal to 1. So it is not matching. So no, then x is odd. Like that actually you have to think. Yeah.
Sir, a doubt. right now in D option you have stated x modulus 2 is equal to 0, right? Usually when we used to write in code, we use double equal symbol. Is it necessary to follow syntax in flowchart, or is this okay?
No, flowchart you can actually follow any kind of symbol. You don't have to necessarily equate it to double equal to actually. Right. So flowchart means pseudocode actually. Whatever is easier for you to understand, you can write it in flowchart as long as you and other people are understanding it. Yeah.
Okay, sir.
Yeah. Yeah. So this is question number 10. And this is the flowchart actually. The flowchart is can you read the flowchart? I think you can read actually. So this is the start, and then by following that arrow, let me explain the flowchart. Read x, you basically read the value of x, and then you assign the value of 0 to y, and you follow this operation, these two operations, and based on that, you basically uh, do this. Is x equal to 0? If it is yes, you directly print it, or if it is no, then you again go back to this step. Okay. So take a pen and paper, actually try to solve it actually, what is going to happen. And I suggest you create a table of these values so you can keep track of them actually. So each of the row will be one of the step. Take your time, 2 minutes maybe. Then I'll explain it. Otherwise, yeah, I directly explain. It will be a
Sir,
problem.
it is 4, sir. C4.
Why it is 4?
So the
Yeah,
first iteration, it returns x is equals to 264. And it is not equal to 0, so it goes to second iteration. In second iteration, it returns 26. It's not equal to 0, so it goes to third iteration. In third iteration, it returns x is equals to 2. It's not 0, it goes to fourth iteration. And in fourth, it returns x is equals to 0, so it prints y, which will be equal to 4.
yeah, it is okay. So let other people also do it for some time, then I'll explain. Okay. Yeah. So C 4. Okay, so I think it is very easy for everyone actually. Okay, so yeah, let me explain then. So this is a flowchart for calculating the number of digits. Okay. So how the operations are performed. So this is the flowchart. In the step 1, what is the current value of x? 2648. So this is 2648. What is the value of y that is assigned? This is basically 1 from this portion, and x after x equal to x by 10. So if you take x by 10, then what do you get actually? You basically are dividing it, right? Dividing x by 10, and you are getting this value. So if you divide x by 10, and if x is an integer, you basically don't get 264.8. So 0.8 that will be cut off, removed from the thing, and only 264, the integer value of it will be retained. Okay. So that is why only 264 is retained. And after this operation, this first operation, the value of y is 1, the value of x is 264. In the next operation, the value of y will be 2, because you are basically, it is starting from 1, 1 plus 1 equal to 2, and the value of x will be x divided by 10. So you take 26 rather than 26.4, because it is an integer, right? In the second operation, next operation, you get the value of 2, because you are again dividing 26 with 10, and you are assigning the value. So the value of x will be 2, and the value of y will be 3 because previous value of y was 2. So 2 plus equal 1 equal to 3. And so yeah, so after that, if you divide 2 with 10, it will be 0 because there is nothing to divide, and y equal to y plus 1. You basically calculate 3 plus 1 equal to 4. You go here. Is x equal to 0? Yes, you print it. In the previous steps, x was not equal to 0 in these steps. So you go repeat these steps again. So by doing this step again and again, you are basically calculating how many digits are there in this number. So this is how it is done actually. So there are two things going on if you see carefully. One is this is the body of the program. In the body of the program, you are keeping on dividing x with a number and assigning the new number to x. And at the same time, you have one variable to keep track of how many digits are you have actually calculated till this point. So at the first point, the number of digits were 0, and you see the actual value of x, which was 2648. And then after that, you divide by it by 10 to strip one digit from the RHS, right? And you increment the value of y to y plus 1. Then the value of y will be 1. So now one digit is cut off. You increment the value of y to 1. So these are two variables, actually, two operations going on parallelly. So these are the important things that will actually be useful for other questions. Yeah. So any other questions regarding this? Any difficulty to understand what is going on here? Then I'll repeat how it is happening actually, if any difficulty is there. Should I proceed or yeah? So yeah, so the way to read this flowchart is very simple actually. So you start from this start state, then you read the value of something that is given. You see another variable that are declared, assign those values of it. And for complex flowchart, I suggest you to keep this kind of table actually, because this will be very important. Yeah, so yeah, any questions?
That algorithm is basically to calculate the number of digits, right?
Yes, yes, correct. Correct. Yeah, so maybe in exams also this kind of questions will be given in any kind of exam, even in GATE, this kind of questions are given. So the best way to solve these questions is basically preparing this kind of table and then solve it step by step, such that no error in calculation is there actually. Okay. So that is why I prepared this flowchart. I mean the table here. Okay, so coming to this question 11. So these are the setup questions that were, I mean, yeah, given as a part of previous assignment in the previous version of the course, and I tried to show how they look like actually. Okay, and these are the setup questions that are basically some additional set based on the concept that is taught in week 1, right? So yeah, let's proceed then. There are some another 10 setup questions, I think. So yeah, which of the following controls the way in which the computer system works? And again, going back to the basics, computer system works and give means by which users can interact with the computer. There are 4 options: motherboard, operating system, application software, and RAM. So what is motherboard actually? It is a piece of hardware. So read the question carefully and then think of it and I'll answer it.
B option, so the operating system.
Yeah, so somebody has said operating system, maybe application software is also correct, right? So RAM and motherboard are definitely not correct. The reason is that motherboard is a part of hardware and you cannot directly control the hardware. And RAM is also part of the hardware. So there are two options remaining. One is operating system and one is application software. So out of them, you have to choose one. So application software in this sense is very limited because it actually handles only a few things that the computer can carry out. But the operating system is basically very vast. So yeah, the answer is operating system. The reason is that operating systems handle many things from booting up the computer, then handling the memory itself via some logics, then scheduling the processes that will be running in the computer, concurrently running them parallelly, and also handling the RAM. So there are multiple things that are going on inside the computer that are handled by the operating system. So it has lots of different things that it carries out. So the correct answer is operating system. And it also provides one way to interact directly with the hardware and between the user. So that is why it is very important. This acts as an interface actually. Operating system acts as an interface. Application software cannot boot without an operating system. So this is more fundamental actually, right? So the relation between bit and byte in digital logic. This is a very simple question actually. I think everybody knows it. How many bits equal to 1 byte?
1 byte is equal to 8 bits.
Option C.
Yeah. So in binary digital logic, actually, bit means actually 0 or 1, right? So 8 bit means a collection of zeros and ones. So 0, 1, 1, 0, 1, 1, 1, 0. So this is a collection of 8 bits between 0 and 1. So that string of 8 bits actually comprise of 1 byte. So why it is important to quantify it in byte, why not bit? Because we shall see later in the RAM when you design the logics, actually those portions of the RAM, they are represented in byte because they are a multiple of 8 actually. So either you have 1 byte of memory, 2 byte, 3 byte, or 4 byte, like that actually. So 2 to the power actually. So that is how the bytes are represented. Okay. So the option is C. Option C. Okay. So now this is another question. So I think, yeah, just a second. Decimal and binary. So how do you solve this question directly? Let me show you the step actually. So this is 6-bit of number. This is another 6-bit of number. The question is binary AND operation of the numbers this and this results in decimal and binary. What is the value?
हाँ हम कुछ काम कर रहे हैं बाद में बात करें।
Please mute
कुछ
your
काम कर रहे
microphone.
हैं बाद में बात करें।
Please mute your microphone. Okay, so to proceed, we have to know how to actually represent these numbers, and this is how we actually represent these numbers. So 100 101, so 100 101, and 1100 11. So this is the second number. And how to take the AND operation? Do you know how the AND operation works? So there is a truth table. There is a concept called truth table. So if the value of x is 0, one bit is 0, and another bit is 0, then what is the value of x and y?
0.
If x is 0 and y is 1, then
0.
0.
so when it will be 1?
When both are
Zero.
1.
When both
When
are
both are 1.
When both are 1, yes. So when both are 1, then it is basically 1. Otherwise, everywhere it is 0. So if these strings are given, how to do this actually? If you calculate it from right to left again. So 1 and 1, this is, let's say, left bit, this is right bit. 1 and 1 is 1, right? And then 0 and 1, this is 0 because one of them should be 1 to have the value of 1 as the output. Then again you come to this position, 1 and 0, this is again 0. 0 and 0, this is 0. 0 and 1, this is 0, and 1 and 1, this is 1. So this is how it is calculated. If you are given two strings, binary strings, and the question is you have to output the AND of those two strings, what will be the output actually? So if you have to write those two strings like this, then after writing them like this, you just have to perform the bitwise AND operation. So this is called bitwise AND operation because you are performing those AND operations on bit. So 1 and 1 will be 1, 0 and 1 will be 0, 1 and 0 will be 0, 0 and 0 will be 0, 0 and 1 will be 0, 1 and 1 will be 1. So this is the output of performing the binary AND operation between these two strings actually. Okay.
Both A
So,
and C options are right.
sorry.
Both A and C options are gonna be right.
Correct. So yeah, I'll explain it. So you are saying A because this is the binary version of it, and the decimal version of it will be 33, right? So yeah, I have explained how to get the value of A, the binary representation of and between this and this. Now I shall show you how to convert that binary representation into decimal representation. So each of these values actually mean something, right? I mean, this string actually is a number particularly. This string also signifies a number. So how to get that number from the string? That is the important part. So there are two parts of these questions. First, you need to get the binary AND operation output, and after getting that binary AND operation output, you have to actually convert the output into decimal. So how do you do that conversion part actually? So for the conversion part is actually written here, how they are converted. So you just in the upper part of it, you begin with assigning this I mean 2 to the power k. So you begin with 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, and 5, corresponding to the locations of these digits actually. So this is 2 to the power 0. At 0th position, what is the digit that has been produced by the binary and output? 1. So you posit 1 here. At the first position, what is the binary output you got? You got 0 here. So you posit 0 here, right? At the second position, what will be the binary output of this? This was basically 0. You posit 0 here. At the third position, what was the binary output you got after the binary AND operation? This is 0 also. You posit 0 here. At the fourth position, this is also 0. You posit this 0 here directly. At the fifth position, it is 1. You posit this 0, 1. Sorry, 1 here, right? So this is how you form the table. So any problem of understanding up to this problem point?
Sir, can you repeat for the decimal part?
Sure, sure.
I mean,
Yeah, sure. So you write this from right to left, okay? So you begin from right to left, 2 to the power 0, 2 to the power 1, 2 to the power 2. These will be the fixed things actually. 2 to the power will be the fixed thing. So 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, up to the position as many digits are there in the output. So this is 0th position, right? So you write 2 to the power 0. This is one position, first position, you write 2 to the power 1. This is second position, you write 2 to the power 2. This is third position, you write 2 to the power 3. This is fourth position, you write 2 to the power 4. And this is fourth position, you write 2 to the power 5. Do not think about this line now. You just write this line, starting from right to left. Is it clear?
yes, yes.
Yes. After writing that, you see the exponent. What is the exponent actually? This is the 0th exponent. So in the 0th position, what is the value that you got? You directly place it here. Okay. See the first position. What is there in the output you got? This is 0. You take the 0, you place it here. See the second position, what value you got? You got the value of 2. you take the value, you posit it here. See the third position. This is the third position. What value you got? You got again value of 0. You posit it here, this position. See the fourth position. What value you got? You got the value of 0. You posit it here. Fifth position, you get the value of 1. You posit it here, right? After doing this, the table is formed, the full table. Then what do you do? Then basically you multiply these values with these values and take the sum. So 1 into 2 to the power 0 plus 0 into 2 to the power 1 plus 0 into 2 to the power 2 plus 0 into 2 to the power 3 plus 0 into 2 to the power 4 plus 1 into 2 to the power 5. So this is how you calculate it. So all the 0 into part will be gone. So only thing that will remain is 1 into 2 to the power 0 plus 1 into 2 to the power 5. So 1 into 2 to the power 5 is 32 plus 1 into 2 to the power 0 is 1. So 32 plus 1 equal to 33. So that is how the whole process is done. So it is slightly complicated for those who are learning it very new. So if you have any doubt, let me tell. Yeah, tell me and I'll let you know. Again, I'll go through the thing. Okay. Yeah. Any doubt regarding this?
Sir, which answer will be considered as correct, 33 or binary number of 33?
Both actually. So the question is in decimal and binary. So we have to in the question in MCQs and an assignment there will be only one option, either decimal or binary. You have to calculate. But here I am
Okay.
showing you to make you understand the logic. Okay.
Yes. Thank you.
Yeah. Yeah. Is there any other question? Okay, so what will be the value of this actually? What is the value of decimal value of this? Can anybody answer using this table? Prepare this table and actually answer what will be the value of this. And anybody explain actually. So I'm going to the chat section of the Teams, then we'll discuss once. Okay.
Decimal
So
value of
yeah. Just a second. Let me show you the value. Yeah, 100,101.
37.
37, sir.
37.
Okay. Okay, 37. Anybody? Is it 37? What do you think? Why it is 37?
Yes, sir.
Yeah. So let me explain why it is 37. They're telling. So let me create the table here also. Then let me explain. So let me remove these things now. Okay. So these are the fixed. Sorry. Yeah. So the exponent I have already fixed, and then I'll write the numbers actually. So what is the number at zeroth position? This is 1. I'm reading from right to left. What is the number at 1th position? This is 0, right? This is 0. What is the number at second position? This is 1. What is the number at third position? 0. Fourth position? 0. And fifth position? 1. So you now have the whole number 100,101, right? Then you do the summation part. So 1 into 2 to the power 0 plus 0 into 2 to the power 1 plus 1 into 2 to the power 2 plus 0 into 2 to the power 3 plus 0 into 2 to the power 4 plus 0 into 1 into 2 to the power 5. So you just ignore the zeroth part, okay? Because if you just multiply it with the exponent, it doesn't give you anything. So you can just ignore the zeroth part and only consider the one part. So what is the value corresponding to 1? You just sum them. So 2 to the power 0 plus 2 to the power 2 plus 2 to the power 5. So what is 2 to the power 0? 1. 1 plus to the power 4 is 4. 1 plus 4 plus to the 5 is 32. So 1 plus 4 plus 32. What is that? 32 and 37, right? This is how you get the number. Is it clear now? I think it is clear now to everybody.
Yes, sir.
Yeah, let's do the exercise for another number, this number, then we'll see what is the value. So 1 1 0 0 1 1. So let's again start from the right hand side. So the right hand side value of 2 to the power 0 is 1 here. This is also I'm positioning 1. See the cursor. I am in this position. This is 0. I am in this
51.
position.
51, sir.
Yeah. This is the position I'm here.
Answer
1.
will be 51.
Yeah. Let me check. Yeah, correct, I think. Okay. So this is how I represent the numbers. Then after that, we'll calculate we ignore the zero values I have said, and then only focus on this portion. So 2 to the power 0 is 1, or 1 is 2, 2 plus 1 is 3, then to the power 4, right? So what is the 16? So 3 plus, 19, and then this is 32. So 32 plus 19 is what? How much? 51. Okay, so this is 51, right? So this is how it should be done actually. So anybody has any doubt now? Or is it completely clear?
Yes.
Okay. I think I can proceed now. So again, very basic questions. Which of the following is not an input device of computer?
Printer, sir.
Printer.
Printer.
What about mouse? Is it?
Option 1.
Yeah.
Mouse and keyboard usually come attached. So no.
Are they input or output device? Mouse and printer. Sorry, mouse and keyboard.
Input device.
What about the monitor? Is it input and output? What?
Outputs.
Output device.
And if it touch screen, then it is input output, right?
Yes, sir.
Okay, so these are very simple things actually. You can skip it. And this is another flow chart. So this is actually to find the area of a rectangle. So I'm just showing you the flowchart to actually make you understand how to do this. I mean, do these things, implement these things in the computer. So this is very simple actually. So how the area of a rectangle is calculated? It is length into breadth, like so L into H. So how to start constructing the flowchart? Let me. Okay, you have already seen it, so there is no point actually. So let me directly explain it. So this is the start. This is the rounded thing from which you start the thing, and this is an arrow, and this is the rectangle. So each rectangle means this is the reading part actually. When you read some values, then you have to show it in this fashion actually, trapezoid type of fashion. So read length and breadth. So after that, there is this diamond shaped thing. So diamond, whenever you see diamond shaped pattern, you have to know that here I have to identify the pattern actually. If there is, and I have to see whether the pattern comes as true or it comes as false. If it is comes as true, you have to do something. If it comes as false, you have to do some other thing. So after reading the length and L and H, you are checking what is the value of length and what is the value of H, breadth actually. So if the value of length is greater than 0 and if the value of breadth is greater than 0, then you are proceeding actually. If it is false, you are not proceeding. Okay. So if the length is greater than 0 and if the breadth is greater than 0, then you can calculate the area. If they are lesser than 0 or if they are equal to 0, there is no point in calculating the area because it is not even a rectangle. So these kind of constants are very important actually to evaluate because the computer is not able to understand what the rectangle looks like. it only understands logic. So if you don't provide this logic, and if you provide some kind of, let's say, length is 0, breadth is 15, so it will say the value of the area of the rectangle is 0, because it will multiply 15 and 0 and it will give you 0. But it is not even a rectangle. So this kind of physical constraints, that to build a rectangle you have to have non-zero and greater than 0 value of length and breadth. This criteria should be embedded in this golden the diamond boxes actually. Otherwise it will give you output, but it will not physically make any sense. So yeah, so the length and breadth you are calculating. If they are greater than 0, you are basically calculating the area, and if it is basically false, then you bring the invalid output input and then end the thing. So the reason I'm showing this simple thing is because whenever you want to write a flowchart for any program that you are given, you have to see what are the constants, basically, what are the edge cases. And firstly, make all the edge cases and the diamond boxes in the program, in the flowchart. After that, construct the other part of the flowchart, because usually uh, constructing the overall flowchart is easy, but if you don't understand the constant actually, then the appropriate construction will be very difficult, because this is a one edge case actually. If you don't handle this edge case, the program will definitely done, but it will give you some garbage, I mean, non-physical output actually. So for a straight line there is no area, right? But it will give you the area of 0 actually, because it will think that it is some kind of rectangle, because length is 0. Even if you see negative length, it will give you negative area, which does not make any physical sense actually. So this kind of edge cases you should always handle. Okay, so that is why this program was shown here, because it is not very simple to identify those constants. Yeah. Any questions?
No, sir.
Okay. Okay, so this is factorial actually, calculating the factorial of a number. So what is factorial? Let me uh, yeah, clarify actually. So factorial means actually, okay, let me hide. So factorial means if you want to calculate factorial of 5, then you just go backward. So 5 into 4 into 3 into 2 into 1, up to 1 you calculate and stop. So what will be the factorial of 5? 5 factorial will be 5 into 4 into 3 into 2 into 1. I think you already know these things actually. What will be the 4 factorial? 4 factorial will be, you start from 4, go back to 1 and keep on multiplying. 4 into 3 into 2 into 1. Factorial of 17, 17 into 16 into 15 up to 1. You multiply all the numbers. So how to represent it in flowchart? Actually, can anybody tell me how to actually uh, do it in program? What are the steps actually? Then I'll show you the flowchart. What are the steps of calculating the factorial?
So first we have to read the number for which number of factorial, like 10 factorial, 12 factorial, and then we should use a for loop or a loop where we have to take I is equal to 1, and we have to set the limit that I is less than or equal to the number that we have inputted, that we have got from the user, and then we have to multiply. We have to set up another variable and we have to multiply the numbers, and then we'll print.
Correct. Correct. So suppose you are given a value of n, and you know the value of n actually. So let's suppose it is 17. Then you assign one variable which is basically keeping the value of 17, and it keeps on subtracting as you keep on multiplying, right? So it is very simple actually. You have the 17, x equal to 17, let's say. Then you just, in the next step, you do x minus x into x equal to x into x minus 1, right? Or yeah, then you subtract that variable y, which is assigned the value of x. Y equal to x you have assigned, then you assign y equal to y minus 1, and you check is the value of 1 y reaching 1 or not. Whenever it reaches 1, just stop the multiplication. So this is the simple idea actually. So see here. So you start, read the value of n, and you declare two variables. One is factorial and one is L, right? And you do this thing, factorial to factorial into L. So L, as it is 1, it will give you the value of 17, let's say. So if it is n, then it will be 17. Then it gives you the value of 17 here. And if L equal to n or not, if it is n, then you print the factorial. If it is false, you increment L and you multiply again. So then 17 into 2, then it keeps on happening, right? So L is equal to n or not? It is not n. So you go here, 17 into 3, like this. You keep on doing this, okay? After that, you print the factorial when it reaches I equal to n. So this is just beginning from 1 to that number. And whatever I told you is basically uh, that number, starting from that number, going back to 1. So yeah. Any questions regarding how the factorial is calculated or not? Okay, so let me repeat once again actually. So you are given a number, you basically come to this number, this is n, this is factorial equal to 1, L equal to 1. This is another variable actually. You calculate the factorial value by multiplying it with 1. So this is, let's say, 17. You come here, L equal to n? No, because n was 17. Then you increment it, 2. Then you multiply 17 into 1 into 2, right? Because it was 17 into 1 in the previous step. You assign the 17 into 2 here. You come here, L equal to n? No. You increment it. Then 17 into 3. So 17 into 1 into 2 into 3, you get here. Then you place it here, 17 into 1 into 2 into 3. Like that, you will keep on doing this until L reaches 17. So in a way, it is basically 17 into 1 into 2 into 3 up to 16. Yeah. Any doubt?
No, sir.
Okay. So now coming to binary addition. So just a second. Drag it here. So this is binary representation, and this is how binary addition is done. So this is very important actually. So these are two numbers, right? 10111, 10111, and 1100001. So how to represent these two numbers using these two digits actually? So just let me move away from the slide slow, and then actually I'll do this myself, okay, to understand easily what is happening. So let's just remove it. Okay, I think I could remove. I don't know how to do it first. I directly remove it. Everything is getting removed actually. Okay, let me manually remove it. I don't know. Okay. Is problematic. Okay, so this is the A and B. So these are the two binary numbers that are given here. Okay. So let me show you the binary numbers, how to represent them. So this is A actually, 1, 1. Read from this portion, 1, 1, 1, 0, 1. Okay. So 1, 1, 1, 0, 1. And this is the second number, 1, 1, 0, 1, 0, 0, 0, 1 0 0 0 1 1. So one number is more than the B is more than A actually. So always you can place 1 0 at the left hand side of any number, right? Like in decimal, you can do that in binary also. So you place 0 here. So now you do the binary addition from left to right. So these are the two numbers that are represented. This is A, this is B, this is A, this is B represented. Then you calculate the sum. So 1 plus 1, what is that? 1 plus 1 is not 2, right? Yeah, you cannot do it like that actually. So it will be 1 0. So for that, you take place 0 here. Why it is 1 0 actually? Because remember that part. So let me build another table here. Table, insert table. Second. If I insert this table, let's say here, just a second, drag it here. To the power 2 to the power 0, and this is 2 to the power 1. So if you provide this as 0 and this as 1, okay, you place 0 position 0 and 1 position 1. Then what will be the output actually? What is the decimal value of it? 0 into 2 to the power 0 plus 1 into 2 to the power 1, right? So 0 into 2 to the power 0 is what? 0. 1 into the power 1 is 2. So how to represent 2 in binary? 1 0. So 1 plus 1 is basically 2, right? In what is that called? Decimal. But you cannot represent 2 like that. You have to represent it in 1 0. So you place 0 here and you take carry as 1. Okay. So now you know how the things are calculated in decimal, right? So if you let's say if it is exceeding 9, then you take the carry. Let's say if it is 10, if you are multiplying, let's say 25 plus 25 or 26 plus 26 plus 25, let's say, then you do the addition. 6 plus 5, it is 11. You take 1 place 1, carry 1. The same thing is happening here actually. It is exceeding 0 and 1, so you place 0 and I mean the 2 like that actually. So this is 1 plus 1 2. We represent it like 1 0. You place this 0 here and you take the carry over there. Then 1 plus 1 again, you sum the carry and the sum end actually. So this is 1 plus 1 plus 0. Again you are getting 2. So you place 0 here and 1 here because 2 is represented by 1 0. Again 1 plus 1 plus 0. Again you are getting 2. 0 here, 1 here, 1. Directly you can sum it up now. 1, right? 1 plus 1 2 again you are getting. So 0 1 here, 1 plus 1 2 0, and you directly place the A here. So this is how the binary sum is carried out. Do you understand these things?
Yes, sir.
Okay.
Yes, sir.
Hmm. So let me verify these numbers, okay? If the sum is correct or not. So how do we verify for that? We just create another row like this. Insert row above. So you just have these numbers 2 to the power 0 here, 2 to the power 1 here, sorry, 1 here, 2 to the power 2 here, 2 to the power 3 here, 2 to the power 4 here, 2 to the power 5 here, and 2 to the power 6. So what is the number A? So you just see the numbers, these portions. This 2 to the power 0 means 1, right? 1 plus 2 plus 4. 1 plus 2, 3 plus 4, 7 plus, what is it? 2 4, 4, 16. 23, right? So A is 23. Okay. And what is this? 1 plus 16, 17, 17 plus 32. What is that? 17 plus 32? 49.
Yes.
Okay, so now take this sum. So everything is 0. To the power 3 is 8. And this is to the power 6, 64 plus 8. So it is 72, right? 62, 60, sorry, 8 plus 64. It is 72. If you sum them, is it 72? 9 plus 3, 2, 1. Yes, it is 72. So it is correct. So do you understand how did I do it actually? Anybody has any doubt? So let me recap it once. This is very important actually because these things will be there in exam and other stuffs. This is very basic actually. So this is the value of A, and you represent it like that: 1 0 1 1 1 1 0 1 1 1. And this is the value of B: 1 1 0 0 0 1 1 1 0 0 0 1. And you can place any zero on the left hand side of A. Okay, so you place 0 here. After that, you carry on the summation. So right now you have A and B, and you carry on the summation. 1 plus 1 is 1 0. So you place 0 here, you carry 1 here. As simple as that. Remember it like that. And then you take the sum of these things. 1 plus 1 plus 0. This is again 1 0. You place 0 here, you take 1 here. 1 plus 1 again. So 2, it is 1 0. So 0 you place here, 1 you place here. Now it is 1 plus 0 plus 0. So directly you place 1 here. Now again in the second half, you get 1 plus 1. You place 0 here, 1 here in the carry, and 1 plus 0 plus 1. Again you place 0 here, you place 1 here. So this is the overall sum. Then using the quotient formula, I am converting it into the corresponding decimal numbers.
If we get
Yeah.
triple one, X has a one, A value one, and B value one. What is its answer?
I did not get your question. Can you repeat? Sorry. Can you please repeat once? Actually, I did not get it.
If you want to add 3 ones, what is the output, sir? So if here we add both 1, it is considered 1 0. So we have to put 0 and then we have to carry 1. If I want to add 3 ones, what is the result, sir?
It will be 1 1, because if you see this is a good question actually. So lots of noise is coming. I cannot hear you actually. So yeah, write it in the chat box maybe. Whatever your question is. Yeah, 1 plus 1 plus 1. Yeah, let me explain it actually. So let's suppose this is 1, then how to handle it? Then I can see this table. So if it is 1, let's say, then what is 1 plus 1 plus 1 means 3 actually, right? So you have to represent 3 in a proper way, let's say. So how to represent it like that? So this is 2 to the power 0, and the corresponding bit is 1. So 1 plus 2 to the power 0 is 1, and 1 plus 1 plus 2 to the power 1, that is 2. So 1 plus 2 equal to 3. So you can represent 3 like 1 1. So you place 1 here and take carry also as 1. Okay. So does that answer your question? So for example, let me clarify, duplicate it. Okay, so for example, let's say the number is this. Okay, so these are the two numbers and we don't know the sum of them. Okay, these are the two numbers. So what are the values of this 1 plus 1? Right, so 1 plus 1 means 0 as above, and then you place the carry as 1. Then 1 plus 1 plus 1, so this is 3. So the placement will be 1, the carry will also be 1. Then 1 plus 1 again 2, so here it is 0, it is 1. So you place 1 directly here. Just summing it. 1 plus 1 0, you place 1 here. 1 plus 1 0, you place 1 here. Is it clear now? Whoever asked the question, 1 plus 1 plus 1.
Yes, sir.
Okay. So I'm doing it again actually for slowly for you everybody to understand. So suppose these are the two numbers. So we'll verify it actually in decimal. First, let me calculate it. Okay, just a second. Yeah. So yeah. So this is the number A. What is this number actually? 2 per 0. This is 1 plus 2 plus 4. So 7 plus 16, right? So it is again 23. What is this? 1 plus,
Yes, sir, 23.
yeah, 1 plus 2. This is 3, and this is what is that? 16. 19 plus 32, right? 51, na? So the sum should be equal to 74. Okay, let me check. So 1 plus 1, what is that? 2. So 0 here, carry will be 1. Now see 1 carry, 1 is here, 1 is here. So 1 plus 1 plus 1. You place digit as 1 and you take the carry as 1. So 1 plus 1 now, again here 0, here 1. You take the sum here 1. 1 plus 1 equal to 0. You take the carry as 1. 1 plus 1, 0. This is the carry, directly you are placing it here. So this is the sum. Okay. So 2 to the power 1 is 1. This is 2 to the power 3. This is 8. 8 plus 1 equal to 9. And this is 64. 2 plus 8, right? There is some mistake, I think. 2 to the power 1 is what? 2. And this is 2 to the power 3 is 8. So 2 plus 8 is 10. And this is 64. 64 plus 10 is 74. No, this is correct actually. So please verify it once. Yeah. Sorry, is there any question? Hello. Why you put 1 in sum in the last, then why didn't you put 1 in carry?
Yeah. Yeah.
Oh, so in this position you are saying, so no, this is the ending position, na? So directly we can place the last one at the last position actually. So 1 plus 1 0 and directly carry, we place the carry here. So similarly, you do the decimal addition actually. So let's suppose you are doing 5 plus 6 11. Then you take the position, I mean 5 plus 6 11, you place 1 here and take carry 1. Then there is nothing to add actually. Then you directly place the 1 here actually. Think of it like that. I think it is clear, right? Any other questions? Okay, so apart from that, there are some other questions, I think. So yeah. So now how to convert decimal into binary? We'll shall see that. There is one process, but we'll see the easiest process actually. So for that, you let's suppose you want to know the binary equivalent of 17. So how do we do that actually? So again, you create this thing, this table. So after that, you see how to represent 17 uh, in this position actually. So 17 means actually what combination of these things will make you a 17. So you place first 1 here, 2 to the power 0 into 1. What is that? 1. So how many more do you need actually? 17 minus 1 is 16. So you need only 16. So how can you get 16 by 2 to the power 0? 2 to the 4, sorry. So if you place 1 here, you'll get 2 to the power 4 plus into 1 plus 2 to the power 0 into 1, you will get 17. So every other position will get 0. So this is one heuristic way actually of calculating this equivalent. So to understand this thing, this is very simple actually. So now let's calculate 27, okay? Now let's remove these things. Now what is 27 actually? How to calculate it? So 2 to the power 5 is 32. So it is exceeding, right? So definitely we have to place 16 to the power 4. So let's place 1 here. So how many is remaining? Remaining is, if you place 16 here, then 11 is remaining, right? So how to form 11? This is 1, 8 you can get here. So place 8 here. Then 3 is remaining. So how can you get 3? You can get 1, 2 here. You
To the
can
power
get
of
1.
1 and then 2
Yeah,
to the power of 0.
correct. So like that, you have to do it actually. This is the very simple process. There is one another process also using remainder that I'll show you later because there is not much time left. But this is the easiest process actually. So now suppose you want 33. How to get 33? Just look at this. 2 to the power 5 is 32. Just place 1 here. So you get 32 already. So only 1 is left because 33 minus 32 is 1. How to get it? You just place 1 here. So 2 to the power 0 into 1 is 1. 2 to the power 5 plus into 1 is 32. So 32 plus 1. 33 is done. Every other position will get 1 0. Now let's say 37. How to get it? Just a second. 30, sorry. Not even is the number. 37. Okay. So the 2 to the power 5 is 32. So you place 1 here. How many bits are remaining? 2 to the power 4 is required. If I place 2 to the power 4, then it will be what? Sorry, 2 to the power 2. 1 into the power 2 is 4. 32 plus 4, 36 gone. So only 1 is remaining. I can place 1 here. So the other position will get 0. Okay. Do you get it? This is how you should solve it actually. This type of problems. It is much easier than to do it by the usual method. Any understanding problem in understanding anything?
No, sir.
Okay. So another number I'll give you. So do it yourself and tell me the value, and we'll verify. Okay? This is the number. Just a second. Yeah, 41. Tell me the value, the binary equivalent of it. 100101. Calculate it and let me know.
101011.
101011. Okay. Let me check. So how to do it actually? 41 is 32. We can directly place it where 1. Then how many is remaining? 41 minus 32. So 9 is remaining, right? So how to do 9? So 2 to the power 3 is 8. I can place 1 here, and only 1 is remaining. I can place 1 here. Then remaining portion will be 0. So 1 0 1 0 0 1, right? Or am I wrong actually? 1 0 1 0 0 1 1 0 1 0 0 1. Okay. Yeah, I think it is correct. 1 0 1 0 0 1. Yeah, everybody is saying that. Not 1 1 actually. It will be 0 1. Okay. So somebody has written it like, yeah, 1 0 1 0 0 1. So this is 2 to the power 0 1. This is 8. 8 plus 1 9. 9 plus 32 41. Okay. Yeah, I think for today it is okay. So if anybody has any questions regarding anything, just ask me. So let me recap what we studied. We mostly studied about very basic things, what are input output devices, and how to make the flow chart actually, how to read the flow chart, what are the algorithms that can be represented using the flow chart. Basic questions like what is the difference between program and this algorithm. And the most important thing that you want to get away from this discussion is the memory construction actually, because that will be the most important thing later in the C programming and anywhere in the computer science actually, because these things are literally everywhere. I mean, if you know how to reference one memory position properly, then you can do any problem, you can solve any problem regarding structure and pointer. So there will be multiple kind of brain teaser actually in the next part, later part of the course, where we have to handle this kind of very difficult problems. If you have the fundamentals of memory organization is very clear in your mind, then you'll get to answer those questions very efficiently. We'll see, we'll see in that direction, but I will suggest you to focus on this memory reference and this kind of things. Okay. So this is the important thing. And apart from that, we actually saw how to convert decimal into binary and binary into decimal and how to add two uh, decimal numbers. Yeah, sorry, it's two binary numbers. And there is another thing actually, how to subtract two numbers that we'll see in the later part of the course, maybe in the next week discussion. Okay, so this is all from my side. If you have anything to ask me, or otherwise we can drop up for now.
Sir, can we leave?
Yeah, sure. We can leave. Yeah. And if there is any question, other question, yeah. Thank you. Okay, we shall meet next week then. Thank you.